What is explainable AI? Explainable AI, often referred to as XAI, refers to artificial intelligence systems and models that are designed to provide clear, understandable explanations for their decisions and actions. The goal of XAI is to make the inner workings of AI models transparent, allowing humans to comprehend how and why specific decisions are made. This transparency is crucial for building trust, ensuring accountability, and enabling effective collaboration between humans and AI systems. Importance of explainable AI. First, trust and transparency. Users are more likely to trust AI systems if they understand how decisions are made. Transparency helps in building confidence in AI applications, especially in critical fields like healthcare, finance, and law. Second, accountability. Explainable AI enables organizations to demonstrate that their AI systems operate fairly and responsibly. This is important for regulatory compliance and ethical AI deployment. Third, debugging and improvement. Understanding the decision-making process of AI models helps developers identify and fix errors, biases, and areas for improvement. And lastly, user empowerment. Providing explanations empowers users to make informed decisions based on AI recommendations, enhancing human-AI collaboration. Components of explainable AI. First, interpretability. The extent to which a human can understand the cause of a decision. Simple models like decision trees or linear regressions are inherently interpretable. Second, transparency. The degree to which the internal workings of the model can be observed and understood. This involves making the model architecture, parameters, and data processing steps accessible. Lastly, post hoc explainability techniques used to generate explanations for complex models after they have been trained. This includes methods like feature importance, visualizations, and surrogate models. Methods for achieving explainability. Model transparency. Interpretable models. Use inherently interpretable models such as decision trees, rule-based systems, or linear models where the decision-making process is straightforward and easy to understand. Post hoc explanation techniques. Feature importance. Identifies and ranks the features that contribute most to the model's predictions. Techniques like SHAP, or Shapley additive explanations, and LIME, local interpretable model agnostic explanations, provide insights into feature contributions. Surrogate models. Simplifies a complex model by approximating it with a more interpretable model. For example, a decision tree can be used to approximate the behavior of a deep neural network. Visualization uses visual tools to explain model behavior, such as heat maps and image classification to highlight which parts of an image influence the prediction. Counterfactual explanations. Provides explanations by showing how altering input features would change the model's prediction. For example, if the patient had a lower blood pressure, the diagnosis would be different. Interactive and user-centric approaches. Interactive interfaces. Develop interfaces that allow users to interact with the model, ask questions, and receive explanations in real time. User feedback. Incorporate user feedback to improve the explanations and align them with user needs and expectations. Challenges in explainable AI. Complexity versus interpretability. Balancing the complexity of advanced AI models like deep learning with the need for interpretability. Highly accurate models are often less interpretable. Domain-specific explanations. Providing meaningful explanations that are specific to the domain in which the AI is applied. What is considered an adequate explanation can vary greatly between different fields. Scalability. Developing explanation methods that scale to large and complex datasets while remaining comprehensible to users. Bias and fairness. Ensuring that explanations do not introduce or obscure biases present in the model. Explanations should help identify and mitigate biases, not justify them. Applications of explainable AI. Healthcare. Providing doctors with understandable reasons behind AI-driven diagnoses and treatment recommendations, ensuring they can trust and validate AI assistance. Finance. Offering clear explanations for credit scoring, fraud detection, and investment recommendations to regulators, auditors, and customers. Legal systems. Ensuring transparency in AI decisions related to legal judgments, parole decisions, and risk assessments. Autonomous systems. Explaining the behavior of autonomous vehicles or robots, particularly in unexpected or critical situations, to improve safety and trust. Explainable AI, or XAI, aims to bridge the gap between the complexity of AI systems and the need for human understanding and trust. By providing transparent, interpretable, and meaningful explanations for AI decisions, XAI enhances the usability, accountability, and reliability of AI applications across various domains. As AI continues to evolve, the development of effective and scalable explainability techniques remains a critical area of research and implementation. For more explanations of AI terminology, hop over to Ai-Epicentre.com.